So we're here today to talk about our AI agent. We're announcing our AI agent in a slightly different way. We're using the format of a webcast for the first time. But I think, we wanted to do it this way because AI agents are kind of a new buzzword. I think they're kind of everywhere. They're relatively misunderstood from kind of our experience in the market. They're very complicated. And really what we wanted to do here was kind of demystify some of this, but properly introduce what Entopy is doing with its own AI agent and how we're combining that with our AI enabled digital twin. So I'm Toby. I'm the CEO and founder of Entopy. And I'm very lucky to be joined today by people much more technical than me. So Shaheen and Gauss, and if you wouldn't mind introducing yourselves for our audience, Shaheen first.
I'm Shaheen. I'm head of AI at Entopy, and I've started this journey like 2 years ago. And the thing that got me most for the AI is the more you understand it, the more you studied it, the more beautiful it becomes. And it's taken over everything and everywhere.
Yeah,
So it's an exciting time to be alive.
for sure, for sure. And Gauss.
Hi, my name is Kaus. I work as a machine learning engineer at Entopy, and the reason I got into AI was curiosity, and what else can be done
Yeah.
with AI. Like we can do a lot of things with technology, and I was just curious what else can be done with AI.
And I think you guys have one of the hardest jobs within Entity because you have to watch this constantly evolving landscape of artificial intelligence, AI, large language models, AI agents. You have to watch it kind of evolve, understand what's going on, what's current, what's new. And it seems like there's a new release every week.
Right.
And you guys have to kind of keep abreast of all of that. So, yeah, nice job. Anyway, we're going to dig into it. We're going to dive into talking about AI agents and what we've done here at Entopy. But before we do that, I think it would be really helpful maybe just to jargon bust a little bit. So we're going to use a few terms as we go through this conversation. And I think for our audience, I think it would be really, really helpful just to explain what each one of those means. So let's start at the sort of bottom. Let's start with micro models. So Entopy uses this concept, micro modeling. It's traditional machine learning put in operational context. But perhaps, Shaheen, you could just explain a little bit more about what we mean by a micro model in the context of Entopy.
Yeah, that's right. So each operation that we are actually trying to create a digital twin around that operation is containing small bits of works and small atomic pieces of works. One job doesn't have to do anything with the other one. So we take that small jobs and we call them as an atomic piece. And by micro model, the idea is to create the models as small as possible, like the smallest that we cannot break that into two jobs.
Yeah.
So one model can only do one job.
Yeah.
If we do that, we can test it in an isolation. We can make sure of its performance in very different ways. And then we can join them up to have some kind of holistic view of the model's predictions and the performance. So it can be chained up together and create a layer above them. And these layer above them also can be chained. So we can have like a hierarchical of these chains.
You end up with this massive spider's web
Exactly,
of
that's right.
like a hierarchy of like a pyramid of micro models feeding into micro models above them, feeding into micro models above them. But that ultimately is how we deliver the kind of predictive precision intelligence around specific parts of an operation.
That's right.
So then moving into a different domain or context in language models. So, again, I'll come to you on this one, Gauss, if that's okay. But what is a language model?
So basically, language model. Let me get this. So we can't teach machines. Machines they don't have consciousness. They don't have functionality like a human functions. But we want to get something from the machine. All we can do is we can have embeddings or words. We can give it a value. When you give a value to the word, the more important it is in a sentence, right? And that's so. Yeah, when you give it a value, the machine understands. Okay, this word has more value than the other word.
And then it has correlations with
Exactly, with other words. It has correlations with other words. And when it wants to form a sentence,
Yeah.
it forms a sentence based on those values which we give to each word. Now, if you want to say, hi, how are you? Humans can understand it, but for machine to understand it, hi is given a different value, how is given a different value, and once it forms in a sentence, all 3 words or 4 words comes in one sentence, it is given different value. So that's how machine learn. By each word is given different values to it.
And so the primary function of a language model is to interpret and output
Yeah.
language.
So the primary function is basically. So language models are basically trained on different parameters or different databases. So its primary function is when you ask it a question, it can give back an answer. But that answer is basically formed based on the one I have explained previously.
And it's calculating what's the
exactly.
probability of the next word.
Next word, exactly. It's basically probability and vectorization of the words.
Okay, so language models was probably the first instance of this kind of natural language interaction with machines.
Exactly, yeah.
And then came the large language model. So what's a large language model? How's that different to a language model?
Right. So a language model contains limited information.
Yeah.
Even large language model contains limited information, but it's just how much data have we provided to large language model. A language model could be around like 1 million data points. A data points could be each word.
Yeah.
How many words we have given it for training.
Yeah.
A large language model could contain 700 billion parameters. More than that.
Yeah, some of them are
Yeah, exactly.
in excess of 1 trillion now, right?
Yeah, so 1 trillion. It's so more data we give it, more words it has, more properly it can understand a sentence, and it can give a good feedback, a good answer.
Is it fair to say the larger the language model, the more it understands, and therefore the more intelligent it appears?
We can't say it's more intelligent, but we can say it can give a good answer.
Does it appear more intelligent?
Yeah, it does appear more intelligent, but because you see some models which are smaller,
Yeah.
they perform way more better than bigger.
Than specific things.
Exactly.
Okay, so we've gone through micro models to language models to large language models. And then the next step would be to introduce an AI agent. So what's an AI agent, Shane?
So basically, with the large language models, LLMs, we can have these conversations going on with the agent, with the model. So it's basically a huge amount of data fed into a model. It trained based on the words and everything. Then it can output you some results based on what has been trained on. With agents, the thing is, there's a small difference between the large language model and the agent. The core of the agents are the large language models, but the thing is, agent can take in different sources of the data. For example, databases, files, different things. And on the other part, it can actually do something. For example, write you a code, do some cron jobs for you, send you emails, this kind of stuff. So agent is actually something that does something rather than just answering your
So you
query.
get the large language model is fixed, trained on a set number of parameters.
Right.
And then the AI agent, or the idea of an AI agent, is that you have things around that large language model that can add to it. They can give it, workflows to go and do. They can get more information from documents or from web search, real-time information from sensors, in our case from AI micro models, that sort of thing, right?
Yeah, autonomously.
Autonomously.
Yeah, exactly.
Yeah, and that's the key thing.
Exactly.
Agency.
Agent, yeah. So it can do it. It can do functions. It can talk to each other.
They can talk to each other.
Yes, you can
Okay.
make 2 language models talk to each other, which we have implemented.
Yeah,
Yeah.
which is kind of freaky.
Yeah.
Yeah, but that's kind of the thing. So you have the micro models, in our case, micro models that are predicting very, very specific. I suppose you could just put micro models into kind of, I wouldn't just put them into the statistical model bracket, but definitely machine learning. Machine learning models, and they're there to predict a specific thing. And then you have language models, which are their entire purpose is to enable you to interact with a machine in natural language. Large language models are, larger versions of that. They just have more parameters. They understand more. They have context and understanding around more of the world, more words, and so on and so forth. And then AI agents are then on top of the large language model to essentially go and retrieve information for it or execute tasks for it.
Yeah, that's right.
Yeah, that's completely true. And there's a confusion in the word AI, that these days AI is considered as ChatGPT or things like
Yes.
that. But the thing is, AI is like more of a general term, that it consists of different methods of doing this artificial intelligence. It's coming from the traditional traditional models to the language models to the agents, and now they're working on the AGIs. So the thing that we are doing in micro model is completely different from the language models. So both of them are AI. It's just
They fall under the
confusion.
same bracket.
Yeah. Yeah, I've seen the
Yeah, exactly. Yeah. So,
Yeah.
language model comes under the bracket of natural language processing, and micro models come into in machine learning. Yeah. So these two are under the same umbrella of AI. So
And
AI
they're
is,
there to do very, very different things.
yes, exactly. They are two very different.
And actually, human beings are really good at natural language processing. Most human beings are really good at natural language processing, but most human beings are not very good at predicting things.
Yeah.
So we intuitively come up with guesses, which is kind of what we see large language models doing with their hallucinations. But
Yeah. So, like micro models,
Yeah.
they are for predicting,
yeah,
and humans want to interact with the models. Only way is natural language processing, which is large language models. Now you have some predictions. You want to know more about it. You can't have. There's one way to do it is using natural language processing language model, which will interpret your natural sentences into
Yeah.
machine learning, into machine language,
yeah,
and then it'll give back an answer. So now you have two different sets of AIs. What do you say? You can say branches,
yeah.
and then you make them talk to each other.
Yeah.
That's what like natural language LLMs and micro model will be doing together.
But it's kind of we are bringing all of this towards kind of the purpose of this session, which is to talk about Entopy's AI agent. But when you start thinking, what is the point of AI agents? Well, if you think about a large language model as something that's really, really good at interpreting, understanding, and then regurgitating text, right? Just like a human being is. But then you get certain things in our context. We have these micro models that are trained on very, very specific data sets that span years to predict that thing moving forward, which you can't ask a language model to do. So I think this is because I think that's where the kind of idea was first born, that Entopy was going to go in this direction. Obviously, we've spent a long time building our AI-enabled digital twin platform, and that consists, as you've already described, of many micro models feeding into an ontology, feeding into a digital twin, with real-time data feeds going into that digital twin as well. Everything's orchestrated to deliver intelligence across critical infrastructure. The way we normally have historically provided or given that information to our users, to our customers, is through dashboard interfaces, through software. So you go into the Entopy application and you have a dashboard that is telling you stuff that is derived from the data and the outputs from micro models that we've put together to deliver those insights. And we sat there and we thought, well, actually, it would be really, really cool if we could make this more powerful and more advanced by allowing the user to ask what they want of the digital twin rather than us have to present what they've asked for via these interfaces. So that was kind of our starting point, wasn't it, really? It was saying, look, let's put a large language model effectively on top of a digital twin. And that would be really, really cool. So starting point was to make it more powerful, more intuitive. But as we've kind of gone through this journey, I think we've uncovered other areas of value. So the second point really is about being able to not just make it more intuitive, not just make the retrieval of information easier, but actually through agentic AI, create these kind of reasoning capabilities or input these reasoning capabilities, which allow the agent to look at what's going on in the digital twin and then determine a best course of action or test a particular scenario. And then the third thing that we've found, which I think is really, really exciting, is historically it has taken Entopy quite a bit of time and effort and development resource to deploy a digital twin. I mean, again, we know we're going into critical infrastructure. We know that critical infrastructure is unique. We know they have different systems. We know they have different geographies. And so we have built a company that is capable of building digital twins rapidly for these kind of use cases. But it does take time. And you have development burden on the front end of a deployment, during a deployment, and on the back end of a deployment when people think, oh, it would be really, really cool if we could see that on a screen, or it'd be really, really cool if we could see that on a screen. And actually what the AI agent is allowing us to do is deploy more quickly, so get to value more quickly, so reducing the development burden on the front end. It's delivering much more capability during that initial deployment, so it's relieving the development burden in the middle of the deployment. And then on the back end, once the digital twin's deployed, actually the user can now ask whatever they want. So we don't have to continuously build dashboards. So I think it's a super exciting tool. We see it very much in those three areas. I'm sure we'll find more value as we go through this. But now, because I've got you guys, I want to now dig into the specific functionalities of Entopy's AI agent and how it plays into those three objectives. So we have three. We have chatbot, we have deep analysis, and we have monitoring at the moment until we come up with kind of better names for them. But I mean, chatbot, I suppose, is kind of the purpose of it is to provide that intuitive interface. But what I wanted to understand is kind of what is chatbot? Let's start there. What is chatbot in Entopy's AI agent? Who wants to?
Yeah.
Who wants to go?
Yeah. Chatbot, as we can see in the ChatGPT and other stuff, it's a way that you have this conversation going on with you and the system. So why are we doing it? Why are we creating it instead of using other stuff? Because what we want to do is to base this knowledge base on top of the digital twin network and the platform that we have. And it will answer based on the database that we have, based on the predictions that we've made, based on everything that we have. So it's the security of the data and the more purposefulness of this chatbot. So basically what it does, it just, you have to go there, just ask anything you want about the whole operation. It will fetch the data from all the predictions, all the actual values, everything inside the operation, and it will come back with the answer.
So I'm looking at an interface that looks very, very similar to ChatGPT, Perplexity, Gemini, all of the usual chatbots that people will be familiar with, people listening to this will be familiar with. But it's different to those because of the data it has access to, right? So rather, unlike, most of these chatbots now have similar capabilities to search the web and so on. You know, when it was just it was a purebred chatbot and it only had knowledge up to a certain point in time, basically when its training run had happened. So before AI agents sort of came into it, you could ask it a question and it would answer that question based on the knowledge it had. So it's all to do with how much knowledge is available to these LLMs as we discussed.
Yeah, it is basically. I mean, it's limited knowledge for. So if you have a customer for some operations or something, we can actually what we have developed is different from ChatGPT or any other language model is we have the data, and we have the predictions, and we can get a proper information from those data. We have the predictions data or any set of data which we store. But GPT or any other language chatbots, they can't do that. It's completely different from them, as we have capabilities of reasoning, we have actions.
All in chatbot.
In our chatbot, yeah, which is right now is there with GPT, but it's completely different.
So we're using the LLMs that are available. So we're using a network of LLMs with access to this web of data through our digital twin. And like we discussed earlier, when you're talking to a human being, they're great at understanding and processing natural language. They're not, and supposing, but they're not very good at making mathematical predictions based on probability of 2 years worth of data on this very specific thing. Right. And what we're saying is our agent in chatbot form can. You can talk to it and you can ask it, what is this going to do tomorrow? And it will tell you, and you can have confidence in that prediction because that hasn't come from the large language model. The large language model has gone and retrieved that information from the relevant micro model underneath.
Exactly, yeah. I'll give you 2 examples.
Yeah.
The first one is traditional chatbot, which everyone can use, GPT. You ask a question, it will answer you if it is not searching web until it has been trained on the data it has been trained on. Suppose it has been trained until 2024 December, it will answer you every question until December 2024. If you want something after that, it needs to search web, right? For our chatbot, it's basically, it will search web, it will search the micro models which we have, digital twin, everything, and it will answer predictions based on future which we are storing, present, and the past historical data which we want. So it's completely different from GPT.
Yeah, well, in simpler terms, GPT is like a knowledge of a person, but Entopy agent is your special, is your expert. So it's been trained and taught how to get this data, how to use this data, and how to show this data.
Amazing. And what within chatbot, we obviously had a couple of key challenges that we needed to overcome. So I think it would be really cool to dive into those. Obviously, not too much detail, but we'll kind of explain. So the first problem was the digital twins that we deploy are enormous. They have huge amounts, well, many databases, huge amounts of data inside them, both real time, so data coming in all the time from sensors, so it's constantly updating. You have historical, you have large amounts of historical data, you have predictive, you have the micro models pumping data into the digital twin via their APIs. So one of the things, I remember the conversation, we were thinking, oh boy, we're going to have to build an API for every aspect of each one of these digital twins, which kind of defeats the point that, you know, the third objective or the third benefit that we see with this of speeding up deployment, it would actually have the other aspect. So how did we solve that challenge?
Right. And for not using API, we had
Yeah.
a language, 2 different language models talk to each other, understand the questions which user has been asking, and reason it, and then so they basically have a conversation with each other, and what kind of question is being asked, understand the context of the question, form more sub questions out of it if it cannot be answered in one question, and then generate an answer.
Okay, let me just unpack that. Sorry, because there's loads of information in there. So the first things first is the question comes in from the user.
Right.
They're asking something in natural language, and they want to understand, they want a specific bit of information, right? So it could be they want a value of X, which is quite simple.
Right.
But to do that, the agent now needs to go and retrieve the right data point from the database. And what you're saying is, to solve that problem, rather than having loads of APIs and telling it where to go, we have created a workflow where 2 agents, 2 large language models will talk to each other, 2 AIs will talk to each other, reason, and develop essentially the way to go and get that information from the database.
Yeah.
So that's why our chatbot is very much an AI agent.
Right. Yeah. And it does it autonomously. We don't need to instruct, you have to do this, you have to do this, you have this task, nothing. It
Yeah.
will do everything on its own.
And then the second part of what you just said, which was sometimes it needs to split the question up into sub questions,
Right.
is because obviously we're sometimes asking quite complicated things, right? So it might be that it needs to go off and pull in lots of different bits of information and solve one problem in a sequence
Right.
of problems to solve to ultimately be able to give you the correct answer.
Exactly. Because sometimes we ask a question which for us it carries a meaning, but for a language model, obviously it has to understand what does that the question stands for. It breaks down the question into sub questions, more simpler form, and then answers, give it back to it. Right. So it's basically, it is talking to itself, and it's trying to have a conversation with the other model and itself. Does this question answer my what user asked?
Yeah.
Exactly. Yeah. So can it return the result which the user wants? And then that's how it has this. We have developed not consciousness, but it's kind of artificial consciousness, we can say, which we have developed for the language models.
I love that. Cool. And then I suppose so that's how we get data. That's how we solve the API problem, which is amazing. One of the other challenges that we had with chatbot was making sure that it didn't hallucinate. So there is a reputation surrounding large language models, and one of the things that's really important to say is I've seen AI agents being used to go and do grocery shopping. I've seen AI agents being used to, come up with marketing campaigns, or the most annoying use of AI agents is sending sales emails on things like LinkedIn and so on, right? It doesn't really matter if you get those wrong, to be honest. Like if the AI agent goes off and does something wacko, it doesn't really matter. There's not a major consequence to it. We're in critical infrastructure, so we're working with some major ports, airports, renewable energy plantations. So if we give bad intelligence, if our AI agent gives bad intelligence, there is a consequence. So one of the big things that we said right from the outset was that we were only going to do this if we could be absolutely confident that it would not hallucinate. We would rather it give no answer than a bad answer. How have we done that?
Yeah, so basically the reason that the model hallucinates is coming from its training. So for example, a term, a word, can mean different things in different situations. And this model has been trained in all these situations. The data entry point that it's been trained on is coming from all kinds of writings. So sometimes you're gonna ask something about a specific thing, a specific meaning of that word, but it cannot understand it and goes to the other meanings, and it will just come up with something else that you just don't want it to be this way. Or sometimes it just generates values or creates things that are not real.
That's the dangerous bit.
Exactly, that's the dangerous bit. It's all coming back to how you trained your model, how you trained your agent to get the data, get the correct data, and how you stop the model from generating more data. So if you let model just coming up with the words and continuous words and sentences, it will go to that phase that it will create more hallucinated words, which is not relevant. So you have to stop it somewhere. It's all coming back to the training, to how to get the data correctly and how to stop it.
So how have we done it? What sort of guardrails have we put in?
It's basically the methods like RAG that we're using, the chain of thought that it's been using both on the deep analysis side and on the chatbot. So basically the steps that Gafsa just mentioned stops that from going into a phase that it just understands it in a wrong way, understand the questions in a wrong way, by breaking up the questions into smaller ones and trying to answer this smaller one, which are in the RAG is more understandable.
So if we put this into kind of like, I don't know, so like my kind of experience of trying to get something right. If I need to get something right, if I have a task to do and I need to get it right, and it's a really complicated task, one of the things that I will do is probably break that into steps, which is what you're talking about in terms of creating the sub-questions. And then when I do each sub-question, because I really, really, really want to get this right, I will check it. I will check it again. I will check it again. I will check it again. I'll ask someone to check it for me. I'll check it again until I'm so confident I ultimately put it forward. And that is essentially what our AI agent is doing.
Exactly, yeah.
Exactly, yeah.
It scores the confidence of the answer given by the LLM.
Yeah, I love that. And do you know that someone asked, so when we were at the Big Data and AI World earlier in the year, which was an amazing event, and we'll be there next year. But someone actually asked me, so I got the agent out. So this was when it was really in kind of demo level. So we're now in live beta, which is why we're announcing it and pushing the AI agent out to release. So we're getting it to kind of check its homework, which I think is amazing. So chatbot, I think, amazing. It's capable of basically answering questions. It can also produce charts, which I think is really important.
You can visualize the data.
Yeah.
and summarize the data. You can have a good report on the data the question you have asked. Basically, it can analyze it. So
It's cool.
it's good. Yeah, it's good.
It's really, really
Yeah,
cool.
yeah.
Then I suppose the second mode is deep reasoning or deep analysis, I call it. But this is where rather than just asking a question and getting an answer from the agent, we actually now want to test a scenario. So I'm in critical infrastructure, right? What happens if we do this for the next 3 weeks? What happens to our revenue? What happens if we close this gate? What happens if we deepen this seabed? What happens if we close this runway? What happens if we expand the passenger terminal? Now, at this point, the agent's now got access to the full digital twin, so it can see what the infrastructure is like. It can see how it's behaved, how it is behaving, how it's predicted to behave. It can see the values that are driving those predictions. And it's now got this scenario. And what we're asking it to now do is figure out, give us a report, give us a best guess as to what this scenario would look like. And this kind of flips the traditional modeling absolutely on its head, because now we've given a digital twin all of the information, as I've just described, to a very, very powerful model, which can now, use all of that information to deduce. What's the big step, the big thing that we've done here to make deep analysis work? I suppose this is kind of reasoning.
Right. So deep analysis, it does work on reasoning and action. It reasons the question it has generated.
So let's just unpack that one. So this is the thing known as react.
Yeah, exactly. Yeah.
So reason action. So it breaks the question up into small sub-questions.
Right.
And then each sub-question, it will act. So it will go and answer that question. It will do an action,
Exactly.
reason on it, and work out whether the chain of thought is still makes sense to follow.
Exactly. And it just does not take the data which digital twin has. It takes that into consideration with other constraints which that operation could, it can make use of it. Like suppose it needs some other constraint, like from data from internet, data from other data sources. So yeah, it uses all the sources it has, and we have given it the capability to do it, and then it fetches the answer, it produces the answer, reasons the answer, checks the validation for the answer, and then produces a proper report on deep analysis. So yeah, it's just not reasoning; it's other data resources.
Yeah, so it's got the reason, the react. So it's following a chain of thought process. It's reasoning and acting throughout that chain of thought process. But unlike chatbot, it has access to the internet, documents, various other bits and pieces.
Other different sources from which might have an effect on the answer or next 3 weeks.
And the answers, if I use deep analysis, it does seem to take a lot longer to respond to me, because I suppose it's going through a much more thorough process.
Yeah, that's right. It goes through the thinking process. So at the start to think that, all right, if I do this, what's going to happen next based on this data? What's going to be the result of this? It goes through that whole process, and it comes back with the bigger answer.
And each time it's doing that, it's checking itself. And
Exactly.
so it's a lot of work that you're actually...
That's right.
So I kind of liken it to kind of giving a junior employee a job to do.
Yeah.
Right. So I've asked it, for example, to produce me an alternative plan to the one that I've currently got, based, including these parameters, and it will go off and do it. Well, actually, I wouldn't say junior employee. It's very impressive in certain contexts, isn't it?
It is. I mean, it can produce answers which for a employee, like junior employer, it would take a month maybe. It can reduce the time.
Yeah, and it's all because it's got this capability, the architecture, and the access to the information.
And yeah, then again, it's the reasoning that we have and the reasoning that are available. Why are we doing this? It's because of the context, because, as I said, it is your expert. So it knows many things behind the scenes. So when you talk about something, it already knows, has some kind of knowledges. So it knows what you're talking about. And based on the data that you already have, it can generate better answers.
Yeah.
So it is basically smart. We're just making it more smarter.
That's a cool way of putting it. And then finally, the sort of third one is monitoring, so background monitoring. So this is where we kind of thought, okay, so digital twin, loads going on. if we identify something in chatbot or we identify something in deep analysis and actually we want to kind of watch it, background monitoring allows us to essentially alert on more or less anything, right?
Yeah, exactly. So you can just ask a question in natural language. Suppose just monitor X or something.
Yeah, so like we work with a major seaport, so you might want to watch a boat, for example.
Exactly, yeah. If you want to watch a boat and just say if this boat or this vessel has changed its speed or location or direction or something in that sense, it will do it. I can just put in the threshold for how long do you want to watch it? Every 5 minutes, every 10 minutes. It depends on your time, and then it will watch it and it will email you every 5 or 10 minutes or whenever there's a speed of change in speed or location of the vessel. So yeah, and it will run in the background.
Yeah.
And at the end, it's gonna summarize everything and just produce you a result, how much it has changed.
And it just, it comes back to the burden of creating software.
Yeah.
So if you want to do each of these alert system or any of these monitoring, you have to just go back to your software
Yes.
team developer and come back, and it's cost effective. So this way you can easily just ask the agent to create you one of these alerts.
And just on that point, because I want to talk about how it reduces the burden. Obviously, we've explained how it's intuitive. We've explained how much more value this is providing through its reasoning capabilities and so on. And the flexibility that it provides the customer to be able to ask what they want. In terms of Arbon, how long does it take to deploy one of these, right? Because digital twin deployments historically have taken years. Entopy is very proud to be able to, proclaim that we can deploy in a few months. What has the agent done? I mean, we've just seen a deployment go much, much quicker. So what are the steps to deploying? I mean, it's create the digital twin, create the micro models, deploy a single interface, and then what do we do with the agent?
Yeah, exactly. Well, it first creating the structure of the whole digital twin. And based on that, we're gonna know that's what kind of data we are looking after and what's these predictions, how the whole operation works. Then we can start working with the training and teaching this agent. The first thing the first project that really took longer, but now we've seen that we could do another project in very quickly in a very short time. It was like a month, I think.
I think it was a month that the micro models were the first part of that.
Yeah.
And then we put a single dashboard to visualize the outputs from those micro models and other data whilst connecting the database. And then the agent was deployed in a couple of weeks. And so
It just took few weeks.
yeah. So like zero to deployment and operationally testing with a comprehensive tool in like a month. So we're now going to sort of jump around and take a look at Entopy Agent and show you kind of what we've been talking about. So, I mean, the first thing, we've brought the agent up on screen now. This is a deployment for one of our customers. We've, of course, had to blur parts of this out just for, privacy reasons, obvious reasons, really. But the first thing that stands out to me is that this agent is, a very familiar sight in terms of how it looks. So I suppose my first question is, fundamentally, for those that are not necessarily data scientists watching this, fundamentally, what is different between Entopy Agent and something like ChatGPT or Gemini?
So basically, the agent that we use is already trained with the domain-specific data. So it's quite like an employee that knows everything around the operation that the customer is doing, and it has access to different sources like databases, digital twin, real-time data, everything that the user can actually provide. And basically, what we have is the ontology that is structured all the data based on that. And this model, this agent is trained with that ontology.
So we've given the agent a lot more knowledge through fine-tuning effectively around this specific domain and this specific customer. And then we've given it access to the entire digital twin and the mental map, the ontology of how to go and retrieve that information, where to go and get that information back.
Yeah, exactly. It's like a specialist that you go and ask some question. It knows where to get the data from and knows what you're asking about.
And in chatbot mode, which is the first mode that we're showing, this is really designed to be, questions and answers, go and retrieve me some information back for the user. That saves them a whole bunch of time. Maybe they can get information, into one place that would have otherwise taken them hours and hours and hours to pull back. But that's kind of what we're looking at, right? So we've just submitted the question up, and this is now going off and retrieving that information.
Yeah, exactly. So when you ask a question, it understands what you're talking about. Then it tries to understand what sources it needs to go and fetch the data from. It gets all the data validated against the question and give you the response based on the question that you ask.
Yeah, and you can see just how powerful some of these answers are, how much detail it can pull back. We can see a comprehensive list that's just come up on screen with multiple parameters. I suppose the next obvious question is, how do we know that this information is correct, right? So how much work have we put into dealing with hallucinations?
So yeah, that's one of the major challenges that it has to be fixed. So basically what it does, it tries to first fetch data and understand and answer you. Then it comes back and put the question against the answer that it generated to understand if it's validated, if it's completely answering your question, and if it's correct. If it's not, it go back and come back with the better answer.
And do we get one LLM to check its own homework, or do we use multiple language models in that validation process?
Well, we are using multiple language models, so it checks.
They check each other.
Yeah, they check each other.
Which kind of makes
exactly.
sense. And it's not just lists or text answers that it can produce. Our agent, we've got it to produce nice visualizations because, of course, this is a much easier way to interpret the data. So maybe you've got a really, really important email to write, or someone's asked you about something and you want to pull together a chart super, super quick, fully trusted. It's pulling information back, and you can pop that into the email and send it off. You've just seen me now switch to deep analysis mode. So this is the second mode with an agent. You can see the question that we're asking it is much more complex. It's scenario based. We're asking it to run an analysis on a future scenario. Gauss, how does deep analysis mode differ from chatbot?
Right. So the chatbot does have access to data, and it is advanced, but deep analysis, it's way more advanced than the usual chatbot which we are using. Right. So deep analysis, we have given it a power to think and reason and then fetch data from a proper source. Basically, it divides a question into different parts, and then each question has its own autonomous behavior to fetch data from sources.
Okay.
It could be internet, it could be data from the digital twin, it could be some other source which we have provided it. As we have already fine-tuned this data, the chatbot and our LLM on the domain knowledge of a particular customer. So it basically fetches back from the digital twin and from other sources, and then it makes a comprehensive statement, comprehensive answer of the whole database, and then it gives the summary to us.
Okay, so I just want to kind of summarize the conversation. I think that, obviously we're super excited about the AI agent. It's a natural progression. I think we're going to see more of this as people try to find ways. People are looking to implement artificial intelligence now into their organizations. I think most people now think of AI as just chatbots, unfortunately. Obviously, it's got a lot more to it than that. I think combining digital twins and large language models in an AI agent architecture, which is ultimately what the AI agent is at Entopy, is the way to go. And I think we're going to see more and more of this. In terms of the benefits of such an approach, like we focus on critical infrastructure, of course. So that's really where I'm going to be speaking from. As an operator, being able to retrieve this information, just by typing a question into a screen or possibly having it on your phone or something like that, super powerful. Yeah, you just want to know the specific situation here. Go tell me. You can obviously predict. You can get predictive intelligence, real-time situational intelligence, historic intelligence through chatbot. If you're strategic at critical infrastructure, you can simulate and test scenarios. So, maybe you're sitting in a meeting with a new client or an existing client, and you're trying to do a negotiation, and actually they want to put forward an operational, term. They have a request. You can model that in the meeting and have a full report that you can send to your team straight away based on your data, and not just based on historical data that you've uploaded into a into a DB based on a digital twin of your operational infrastructure, right? With the micro models feeding into it, with the real-time data feeding into it. And the results that we have seen have been absolutely phenomenal. You know, producing birth plans for some of the largest ports in the UK, predicting flaring in anaerobic digestion plantations. You know, this is really, really powerful stuff. So we're so excited about what AI Agent is now. We're very excited about where it's going. If people do want to get in touch and learn more about our AI agent, our team would love to speak to you. So you can get in contact with us via our website. There'll be a link to contact us directly attached to this webcast. And we are planning to do a few more of these webcasts, I think, over the next few months. And there's some key topics that we want to dive into. But for now, thank you very much, Gauss. Thank you very much, Shaheen. And thank you for listening.